Hey pre-calc, Miss Soli here. Today we are going to talk about ellipses that have been translated. A translated ellipse. Nice. Okay. 4.5. So what we did in the last video was an ellipse whose center was at the point 0, 0, like at your origin, right? So I have x squared over a squared, y squared over b squared equals 1. This was the equation we learned in the last video. Now, if an ellipse has a center that's not at 0, 0, this is what we're going to take a look at today. If the center was at HK, very consistent with the parabola, the vertex moving to HK, right? It would look like this: x minus h squared over a squared stays the same. And then I've got y minus k squared over b squared, still equal to 1. And the relationship with c squared is equal to the difference of these two is also the same. All right, let's go over a couple examples. I want you to find the center, the vertices, the foci, and then also sketch the graph here of the ellipse. And it's going to look like this here. So let's say I have x plus 2 squared over 9, y minus 5 squared over 49 equals 1. Okay, nice that they gave it to us already in the correct form, and I didn't have to make this set equal to 1. This is standard form for an ellipse, and they give you a ton of information here. So from this, I can tell you that the center is, remember that these are the opposite. So whatever is in this parenthesis, the actual point will be the opposite of it. So the center here is at the point -2, same, +5. A, because if a squared is 9, then a is 3. If b squared is 49, square root both sides, b is 7. So with this, I can kind of start drawing my sketch here. And with this, I also know that my ellipse, it's going to have a minor axis because the A is smaller. The minor axis will be horizontal and the major axis will be vertical because the B is associated with the Y, and so the Y is taller or shorter. Okay. So here's a graph. I'm going to kind of make it off to the side because the center is negative and positive in this direction, right? So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, something like that. So the center is at the point -2, 5 right here. The A value is 3. So I'm just going to count. So this is the point -2, 5, right? I'm going to count to the left and to the right. So if this is at -2, I'm going to be on the 5, like the 5, whatever line, and go over 1, 2, 3. This is the point 1, 5. It moved 3 over to the right, and then I'm going to move 3 over to the left. 1, 2, 3. And this will be the point -5, 5. So this is my minor axis here. Now let's find our major. So B is 7. So I'm going to go on this -2 line, this -2 vertical line. I'm going to go down 7 and I'm going to go up 7. So from the 5, 1, 2, 3, 4, 5, 6, 7, 2 below. So this is the point -2, -2, because this distance here of a B is 7. So the 5 minus 7 is -2. And then 5 plus 7 is going to be the point -2, 12, because I'm going up 7. So 6, 7, 8, 9, 10, 11, 12 to right here. This is the point -2, 12. So your ellipse, sorry, a little sideways there. Ellipse is going to look like this. Last step is to find our focus, or both of them, our foci. And they're going to be here-ish and here-ish, right? So I know they're going to be in the circle. So we got to find C. C squared is absolute value of A squared minus B squared. So, and I already know A squared is 9, B squared is 49. C squared then is absolute value of -40. C squared is 40. So C is the square root of 40. You could also write that as break it down into the square root of 4, square root of 10, 2 root 10. But I'm going to leave it here. And this is approximately 6.3. And thank goodness that is less than A or less than B, right? Because if it was greater than 7, it would be outside of my ellipse. And I'm just going to kind of count, right? So 6.3, it's 0.7 shy of the vertex there. So your focus is going to be right there, and then up here 0.7 shy of that one. But how I write these, right? So I went from my center up, like plus the square root of 40. So your first focus is going to be -2 because it's on this line, and then 5 plus the square root of 40. And then the other one is going to be -2 because it's on this line, 5 minus the square root of 40. And again, you can absolutely write this just once as -2, 5 plus or minus root 40. Like that's totally fine. Those two are the exact same thing. All right, let's do another one. This one, I'm going to just give you some information and I want you to write the equation. If the vertices are -2, -1, and 8, -1, the minor axis length is 8. Find the equation. Yeah. Okay. So let's go ahead and graph this. Let's see. My points are negative and positive, kind of a mix. Go like this, because 8 is further out here. So my two vertices are at the point -2, -1 here. And 1, 2, 3, 4, 5, 6, 7, 8. -1 is here. Now I know that this is going to be my major axis because these are vertices. The two on the minor axis are not called vertices. Vertices are only on my major line. And then the minor axis length is 8. So I know that it's going to be 8 tall. But I need to know where the center is. I need to know where the center point is first. The center is just going to be the midpoint here, the middle between. It's going to be something -1, right? Because it's going to be right on this line. In order to find the center, you can count to the middle if it's nice even numbers like that, or add them together, divide by 2. So 6 over 2 is 3. The center point is 3, -1. So right there. And from that, I can use my other thing that I know. The minor axis length is 8. So I know B is 4. Because if the whole length of the minor axis is 8, then I know B is going to be up 4 in this direction and down 4 in this direction. So from here, I'm going to go up 1, 2, 3, 4. This is the point 3, 3, because -1 plus 4. And down 1, 2, 3, 4. This is the point 3, -5, because it went -1 minus another 4. So your ellipse is like this. B is for A, we didn't really define yet. A, what is this length? From -2 to 3, and from 3 all the way up to 8. A is 5. Just get that by counting. I mean, you can do math too, but just count from 3. 3 plus what is 8? From that, I can find my C. C squared is 5 squared minus 4 squared. So 25 minus 16, which is 9. Is that right? No. 25 minus 16 is 9. Square root both sides, so C is 3. So your focus is going to be 3 away. 3 away from this point in both directions. So from 3, -1 up 1, 2, 3, this is the point 6, -1. Ooh. 6, -1, and then over 3 in this direction as well. So 1, 2, 3 will bring me back to the point 0, -1. Awesome. All right. So these are examples of ellipses. I do want to give you 2 examples here of if an ellipse was not written in standard form and you needed to complete the square to get it into standard form. Oof. All right. So if I were given an equation for an ellipse, and I'll show you, you know it's an equation for an ellipse if there's both a y squared and an x squared. Okay, so something to this effect. Now, with this being my standard form, what I'm going to need to do to get these in x minus h squared form is complete the square so that this is a perfect trinomial, perfect square trinomial. If you do need some review on complete the square, I will link a video here if you want to watch that first and then jump back to this. That's fine. Okay, so completing the square. I'm going to break this into 2 parts, my part with the x's and my part with the y's. I don't care about 47, so I'm going to get rid of it. Plus 47 both sides. So what we're going to do here is let's start by factoring. So both of these two, the number that they have in common, the greatest common factor is 16. I'm left with x squared minus 2x. Plus, the number that these two have in common is 9. I'm left with y squared plus 6y equals 47. Okay. Now, I want these two things to be perfect squares. So what you're going to do is take that, that b, remember it's b squared over 2, or sorry, just b over 2 squared. So this one would be -2 over 2 is -1, squared is 1. So I want to add 1 here. And you can absolutely just add anything to an equation as long as you do it to the other side. Careful that this isn't really 1 though. It's 16. So I'm going to add 16 over here. Okay, because then I can write this as 16 x squared minus 2x plus 1. Great. Now for the y's, I want this to be a perfect square. So 6 divided by 2 is 3. 3 squared is 9. I want to add 9 here. But this isn't really just adding 9. It's adding 9 times 9, so plus 81 over here. Y squared plus 6y plus 9 equals then 47 plus 16 plus 81 is 144. Okay. Now I can rewrite this a little bit. I'm not going to do any math here. I'm just going to rewrite this in factored form. Because here, -1 times -1 is +1, and -1 plus -1 is -2. And I can do the same thing here because I completed that square with the 9. 3 times 3 is 9. 3 plus 3 is 6. So I didn't change anything there. I just rewrote it. Now, remember my ellipse equation has to be set equal to 1. So I'm going to divide everything by 144. 16 1/44 reduces to 1/9. And 9 1/44 reduces to 1/16 equals 1. So from here now I can get my center, my A, my B, and from there you can find your focus.